In this video I am going to discuss iteration. Iteration, simply stated, means to repeat something. The reason we need iteration in programming is oftentimes you will find programs that look like this. I is equal to 1, b is equal to I plus 1, I is equal to 2, b is equal to I plus 1, I is equal to 3, b is equal to I plus 1. Now if you look at this program, this set of commands that I've entered, you'll see that this thing appears 3 times. And in the lecture notes I talked about how oftentimes there's a do something line in a for loop. And that do something is always the same from step to step. So in here I've taken 3 steps. First step I had I is equal to 1. The second step I've had I equals to 2. And the third is I equals to 3. And between those steps I've made an assignment for the variable b to be equal to whatever I is plus 1. And so as you read this program, you would say I is equal to 1, b is equal to I plus 1, so now b is equal to 2. Here I is equal to 2, and now I'm going to assign b is equal to I plus 1. And I is equal to 3, I'm going to assign b is equal to I plus 1. So in this case we have b is equal to 3 plus 1, so I expect that if I type in b and hit enter, it'll tell me that b is equal to 4. Now, obviously this could be shortened because of the fact that we have repeated lines of code. So what I'm going to do now is to open up a program to enter in my commands. And here is the editor, and then I can click on this little arrow to have it appear in the workspace as a smaller window. And what I'm going to do is to create a program that is a little bit long-winded. B is equal to I plus 1. And I'm going to try and play it, but it's going to want me to save it as a name. So I'm going to say this is called iteration 0. And let me clear the screen, CLC, and then clear all variables. So now the workspace is empty. MATLAB doesn't know about any variables or any assignments that have been made. And I'm going to execute this program. And by executing it, with this green play button, I've done the equivalent of what would happen if I just typed in these things manually. And so program just allows me to shorten that process and just to repeat it easily. Nothing appeared on the command line, and the reason is because all of my commands in the file were terminated with semicolons. And so I can check to see what the value of b is. B is equal to 4, and I can enter an I is equal to 3, which you probably guessed by looking over here in the workspace area where it's telling me the values of these different variables. So now I want a shorthand notation for this. And this is how I'm going to do it. And this is how MATLAB defines the shorthand notation. It says for I is equal to 1, 2, 3. And then it's an end statement. And now all this says is that make 3 steps with I having values of 1, 2, and 3, and then do some repeated part. In this case, the repeated part is this. B is equal to I plus 1. Now I hit save, and now if I hit this, if I delete this, save, and then play, what I'll find is that it's executed, and indeed it's found the value of b to be 4. And so doing this was exactly identical to this. Now the key thing to remember here with iteration is what you put between the 4 and the end can be nearly anything, as long as it's the same from step to step. So if I did this, c is equal to I plus 1, and as long as I have that repeating block to block, step to step, then this thing can be shortened to this. C is equal to I plus 1. And the reason is that it's repeated here, it's repeated here, and it's exactly repeated here. If it wasn't the same, if I had something like c is equal to 3 here, c is equal to I plus 3 here, and then c equals I plus 1, c equals I plus 1, I would not be able to use this shorthand notation because whatever goes between the 4 and n has to be the same for all values of I. So let me reset this as c is equal to I plus 1. And perhaps I'll make this more interesting by saying this is c is equal to b plus 1, c is equal to b plus 1, c is equal to b plus 1. Now it's probably easy for you to look at this program and think about what's going to happen as you read it going in this direction. I is equal to 1, b is equal to I plus 1. Well, that means b is equal to 2. B is equal to 2, and now I'm going to assign c the value of b plus 1, so I should get c is equal to 3. So let me just verify that. CLC, I is equal to 1, b is equal to I plus 1, c is equal to b plus 1, and so as I said, at the end of entering this command, I should have the value c is equal to 3. And then you can continue on to figure out what c is going to be at the very end. And so let's do that. I'm going to copy this block of code, Control C, and I've left off that last semicolon because I want it to tell me what c is at the very end. And paste, and it enters in all those commands and tells me that c is equal to 5 at the end of this. Now my claim is that because I had this block repeated, this B and C block repeated 3 times, that I could use this shorthand notation. But to make it correct, I need to update this so that whatever's between the 4 and the end is the same thing as that repeated block. So let me do a save, and let me make sure that I get the same value at the very end here. Save. I'm going to clear all the variables, so the workspace over here on the left is empty. CLC to clear the screen. And what's going to happen when I play this, when I execute these commands? Well, I see nothing in the command window, and the reason is because I had semicolons everywhere. And I can ask it what the value of c is, and it tells me it's 5, or I could just look up here to see what the value of c was. Let's try this a different way. Let's take off that semicolon, and this is a good way to figure out what's happening step by step. Do CLC, and I can run it by hitting the play button. Now what happens is it tells me that it's going through 3 steps. The first step, I was equal to 1, and it does this command, but then doesn't say anything because I have the semicolon, and then it does this command, and then tells me what the value is. C is equal to b plus 1. So the first step, c is equal to 3. Second step, c is equal to 4. Third, c is equal to 5. 3, 4, and 5. So now let's compare that with what I claimed was happening with an equivalent set of commands up here. So let me take the semicolons off here, and let me copy and paste these commands into the command line just to make sure that that shorthand notation is giving me the same result as that longhand notation. And sure enough, it reports c is equal to 3, 4, and 5. So, a for loop is just a way of doing shorthand. As I mentioned, oftentimes we will want to leave off the semicolons in loops just so that we can see what's happening step by step. So if I'm trying to figure out how this program works, one thing I might want to try and do is take off the semicolons and also put the letter I here. And the reason I do that is because this is equivalent to just typing in the letter I on the command line. So let's clear the console and then let's run this. And what it's going to tell me is exactly what's happening step by step. It tells me that first it set I equals to 1, and then this is just the interrogation command where I'm asking it what's the value of I, and the first step it was 1, and then it says set B is equal to I plus 1, and it reports okay, B is now 2, and then it says set C is equal to B plus 1, and it reports C is equal to 3. Now the way these loops should be read is that when you execute these 3 commands and then hit an end statement, you ask yourself the question, is the value of I at present equal to the last value of I in this list? And the answer is no, because the value of I was 3. And because you're not finished, you continue on and you just repeat this block of commands again. But you repeat this block of commands with only one change, only with the change of the value of I. So the first time through, it does these 3 steps, and then the second time through, it sets I equals to 2, and this is what's being reported just by entering in the letter I, just so we know what it is at that time. And then B is equal to 3 and 4, and then I is equal to 3, and B is equal to 4, and then C is equal to 5. So this is a good way to figure out what's happening in a loop at any one time. So you can imagine if I did 1, 13. Let's take a look. CLC, and then I'll run it. And what happens? It tells me that in the first iteration it sets I is equal to 1, B is equal to I plus 1, so it's 2, C is equal to 3. Now the second iteration, it sets I is equal to 13, because the way iteration works is that it just goes through and repeats this block of commands for every possible value of I that's specified in this array. And in this case, I've specified in this array to have the values, 2 values, the value 1 and the value 13. In principle, I could do it 1, 13, or I could do 1 in steps of 1 to 13, which is the same thing as doing 1 to 13. I could do 1 to 13 in steps of 2, and really any valid array that I want to create there for I would work. Let's see what happens. Let's go from 1 to 2 to, let's say, 130. And now I put semicolons here, so it doesn't tell me what happens at each step. CLC, and then execute. And what happens? It has done many iterations, and each iteration, the value of I is 2 bigger than the previous. So let's verify that at the very first step. I is equal to 1, and then I was equal to 3. And previously I had some stuff printed out between the 1 and the 3 because it was telling me what was happening when it executed these commands. But now I've suppressed that output by putting the semicolons. So this concludes the introduction to iteration. In summary, iteration, or the for loop, is just a way of doing shorthand for commands that are repeated. And so anytime you have a command that is repeated over and over again, it's a likely candidate that you can rewrite that block of code as a for loop.